Hello and welcome to Hepco Live. Thank you very much for joining us today. And we've got some really incredible developments to show you from both Beckhoff and Hepco. Really exciting innovations that we're looking at, which are in various stages of development. First of all, we're going to take a look at the Hygienic System, which really moves XTS into new applications, new areas, wet, harsh environments. Next up will be the high drive system, which again is moving XTS into new areas of applications, increasing its payload capacity. Following on from that, we will then be looking at the track management system, which is an incredibly well-engineered, very clever piece of technology from Beckhoff and Hepco, allowing us to switch between tracks. And then finally, arguably my favorite, the Agile system, which is really an impressive development which maximizes the throughput performance of XTS. Okay, so those of you that have joined us in the past will no doubt recognize me. My name's Alec Dick. I'm the HepcoMotion Business Development Manager, and I've had the pleasure of being part of this team for the past 18 years. But I'm really pleased to say that I'm joined and backed up by a team of experts today. To my left, first off is Dan from Beckhoff.
Thank you, Alec. Well, welcome everybody. My name is Dan Manners. I've been with Beckhoff for 10 years. My primary role, if you like, is as a vertical market manager with a focus on end users. And with the end user role, if you like, a lot of the projects are involved in quite complex XTS applications. So I've been involved from the beginning, if you like, working with Hepco. And I've almost become an extension, if you like, of the XTS team in Unveil. And very pleased to be here today to show you the latest developments.
Yeah, Dan's a very familiar and welcome face here at Hepco. So also joining us remotely, we have Tim.
Hi, my name's Tim Page-Brown. I'm a senior design engineer here at Hepco. I've been with the company for 9 years, and 8 of those years have been working with XTS.
Thank you, Tim, and great to have your experience on board today. And then finally, last but not least, all the way over in Verl, Germany, at the Beckhoff HQ, Rob.
Hi, yeah, I'm Rob Rollick. I've been with Beckhoff now 21 years, 12 years in the US, and now 9 years in Germany. And I work primarily on the XTS for the last 8 years, and my major focus is to back up all of our subsidiaries worldwide when applying XTS systems.
Yeah, thank you, Rob, and thank you very much for joining us today and bringing your valuable experience to this presentation. Okay, so that's enough about us, but of course, both Hepco and Beckhoff are global companies. And first of all, we're going to tell you a little bit more about who we are. So Hepco is a UK-based family-owned company with our headquarters right here in Tiverton in Devon. Supporting our manufacturer, we have our bearing plant in Braintree in Essex. Over in Europe, we have branches in Germany, France, Benelux and Spain, and every team has their own field applications engineers supporting our customers. Further afield in Asia, we have Hepco Korea that are supporting the key industries over there, such as electronics and green industries, such as EV battery manufacture. Beyond that, we have a comprehensive network of distributors which really know our products well and again are there to support you. Hepco was founded over 50 years ago on V technology, which still underpins our core products today. And the V range really can go from a few grams moving on a single axis up to hundreds of kilograms on multiple axes. But of course, we're not just about straight lines, we're also about sort of continuous motion. Our ring and track technology is what really has sort of enabled Beckhoff to enhance their XTS and move it into new areas and applications. And Beckhoff and Hepco themselves, we have a shared philosophy. The complementary technologies have really created a market-leading solution in asynchronous intelligent motion. And now we'll go over to Dan Manners to tell us a little bit more about Beckhoff and their XTS.
Well, Hans Beckhoff's vision from the early 80s was to utilise the power, fast-paced development and economy of scale of the PC. For those of you who don't know us, we're a world leader in PC control technology. This year we might well be a €1 billion company. At Beckhoff, we believe in empowering engineers to innovate and develop systems more quickly. We do this really by providing a modular, scalable solution, but also we believe in open standards. Now, a good example of this is the EtherCAT field bus. It's a deterministic field bus that's Ethernet based, and Beckhoff made it an open standard. It's grown to become the most highly adopted field bus in the world and is indeed probably the fastest. We also believe in taking as much as possible into the software domain. This gives us the maximum modularity and flexibility, but we haven't had to create a new environment, if you like, for the XTS or a new platform. It's merely integrated into our existing unified control software, which is TwinCAT. Rob Rawlick will be talking about this a little bit more later. Because it's just another module, it fits, integrates, and synchronizes with our other motion products, such as standard rotary servo motors or indeed robotics. Now, having a strong modular foundation allows the XTS products and tools to grow, if you like, in a structured way without any significant changes. Now, a good example of this is when we started off with the XTS, our normal system, if you like, would be 16 meters long, about 28 movers. Now, today, we can reach 120 meters with about 180 movers. And this is all possible with the modular approach. I think what's interesting is Hepco have worked very hard to mirror this, if you like, and become a modular, develop a modular system.
Thanks, Dan. Okay, so that's a little bit about our companies and who we are. And of course, when we're working with you, the customer, on your XTS and GFX projects, this is very much a three-way partnership. You know, Beckhoff and Hepco and the customer all communicating together. And, you know, I'm confident in saying that the support you will get with your projects is second to none. We are market leaders in our respective technologies. And of course, talking about the technology itself, you know, although the developments we're looking at today is relatively new and XTS and GFX is relatively new, but the technology that we've built up behind this has been around for a very long time. So let's take a look at some of the underpinning technology. So although GFX and XTS is relatively new technology, the mechanical guide system that underpins it has actually been around for many, many years. The V-guide technology itself, we've been doing it for over 50 years now, and it's still part of our core product. And really, there are many features of the V-guide system that lend itself incredibly well to Beckhoff's XTS. Some of the core features are its small contact point. When we look at the contact point between the V-bearing and the slide, it's very small. This means low friction, okay? So it allows for very accurate and precise, smooth, fast motion, okay? It has eccentric adjustability on the bearings. This means that we can very accurately control the preload from one mover to another. So whether you've got 2 movers on a system or 100 movers on a system, the preload and therefore the driving force is very consistent between them all. In addition, if we look at the bearing design, it has a circular race, which means you get very uniform acceleration within that bearing race as it rotates. So this allows it to be very agile in terms of its acceleration, deceleration, and also for very high speeds as well. And then finally, one of the key fundamental benefits of a V-guide system is its self-cleaning ability. The wiping action of a V-guide is really good at removing dirt and debris from a slide, but also it's incredibly efficient at distributing our lubrication around the track. Okay, so of course what we want to take a look at is the actual detail of the GFX design itself. And who better to tell us but one of our very own experts, Tim, who has been there from the start of this design process. So Tim, really the question is, where did all this start?
Well, for me, this started about 8 years ago when another interesting one-track project landed on my desk, an innovative drive system that was a perfect match for the one-track technology. We're using a clothoid transition, which was very important to the customer, and we worked up a number of ideas until we had a solution.
Yeah, and it's very interesting when I look at sort of the one-track design and where we are with GFX today. It's quite a different beast. You know, I mean, how did we really get from that original one-track design to the GFX that we see today?
Well, that's an interesting question. I mean, we started with one track. GFX, as it stands now, is still partially a one-track system, but it's expanded through developments from Beckhoff. So we have to have a larger ring and track type system, our PRT2. And this is all incorporated now into GFX family. So we have a 3-bearing carriage and a 4-bearing carriage. We have a structure that supports the motor and maintains that essential relationship between the magnet and the motor and the encoder, and is stable.
Yeah, and that's a very good point. And one of the sort of key benefits that I hear from our customers is the fact that this structure, which is modular, the base plate itself can actually form part of the machine base. But of course, you know, there's lots to it. You know, you've got the machine base, the base plate, the motor brackets, the track system, and the movers themselves. You know, I mean, can you tell us a little bit more about the various features of those?
Well, yes. I mean, we're very conscious that we need a very stable structure. So to reiterate that, but it's also a customer interface. So we have allowed for customer fixings either from above, from below, all of those small detail features within the entire system, which allows for simple and regular integration into a larger machine.
Yeah, thanks, Tim. And of course, you know, what we're looking at today is some brand new developments for XTS and GFX. And, you know, really the big question is, you know, what's driven those developments?
Well, demand, customers, acceptance of what is essentially a disruptive technology. The XTS is very different from traditional drive mechanisms. There's no mechanical link between the mover and the drive motor. As you know, customers can be very demanding and have an ability to expand the envelope of need, the adjacent possible of applications. They'll always take the technology one step further than you thought it was going to go.
Absolutely. And just to be clear, we love demanding customers, and particularly Tim, you know, he loves a challenge. So, you know, I mean, we've worked with some really big customers, the likes of L'Oreal. You know, they've encouraged us to make bigger and longer tracks, more movers than ever. And I know that both sort of Beckhoff and Hepco have really worked together to accommodate these new applications and why we're moving in the directions that we're seeing today.
Yeah, for me, it's been absolutely fascinating to watch the development of XTS over the years. From the very simple systems that we saw early on, which could have perhaps 18 or 24 movers and be 4 meters long, 5 meters long, to now where we're seeing track systems of 50 meters, 200 movers. It's incredible.
Yeah, brilliant. Thanks, Tim.
Thanks, Alec.
Okay, so that really gives you a flavour of who we are and, of course, our technology and how we've sort of developed the GFX system into what we see today. But of course, we've been teasing you up to now. What you really want to see is the latest developments that we've been working on. So let's go straight to one of those. The first up is the Hygienic System. And really, this is a design that allows XTS to move into new areas, new applications that we couldn't previously consider. So water, as we know, generally it doesn't mix very well with electronics, Dan. And of course, we have similar challenges with the mechanics. How can you realistically get the system that can work in an environment that requires some sort of washdown process? Let's take a look at the Hygienic System.
So here we have our hygienic design, and for a hygienic application, simply being waterproof and chemical resistant isn't enough. To truly be a hygienic application, we need to make sure that there's no tiny gaps, so no gaps smaller than 4 millimeters. All the gaps in the system need to be able to be cleaned properly so that nothing can accumulate. The same thing for trapping water. Water can't be allowed to trap anywhere in the system to grow bacteria. Once we've done that, then again, we also have to clean the entire system. And that means that we need to be able to use stronger chemicals on the system, the entire system. Everything needs to be able to handle that so that we can clean the system properly in place without having to dismantle anything. Another key item for hygienic application is to keep all these cracks non-existent. We put a gasketing between every metal to metal contact. This becomes important between the motor modules. So in the gasketing between the motor modules, we actually have a stator coil there. This keeps the magnetic field properly aligned between the motor modules, so there's no gap in the field, and the movers will move perfectly smoothly over this gap between the two actual motor modules. Another thing that we had to redo for the hygienic system is the connection between the motor modules. Every motor module can be an in-feed module and accept power. So there's a connector on one side of the motor module that is either a bridge connector or a connector to a cable that brings in all of our power and data communication.
Okay, so yeah, thank you, Rob. That was a really fascinating look at the Hygienic System, and what a fantastic design. I mean, the things it's a work of art, Tim. Great job. And looking at the design, it looks substantially different from a standard GFX where we've got the solid base plate and such like. Can you talk us through some of the differences between the systems?
It's more similar than you would think. The track system is fundamentally the same. It uses a very similar mover geometry. It's just we've opened up the back so that there are no traps, there's no chance of pooling. Access is good for cleaning. The joints are sealed. So it's not that different. It just looks very different.
Okay, that makes sense. So, if we were looking at, say, a food type application, then what we've got is effectively no nasty places for food to sit and go nasty and contaminate your product.
Absolutely,
okay.
Absolutely. The design is there to allow in situ cleaning. So whether it's low pressure washing, detergent and hose down, foaming, that's what it's designed for, is to allow that cleaning in place. Okay.
And, obviously you're talking about sort of clean downs, wash downs, and I know that they use sometimes some fairly harsh chemicals. What have you done in terms of the materials, protecting the material from corrosion and from these chemicals?
Well, the corrosion resistant coating that we use on all the aluminium components is very resistant to most cleaning chemicals. There are some which are more aggressive than others, and abrasive cleaning is rather difficult to deal with. The seals that we use are on the main structure are silicon, so they're very resistant to most chemicals. Strong alkalis and strong acids are always going to be difficult to deal with.
Yeah, no, I appreciate that. And of course, I've got one of the sort of standard GFX movers here, and you've got a hygienic specification mover there, and I can see that there are a number of differences. For instance, you've got a cutaway in one of the surfaces. The bearings clearly look different, and it's a different colour as well. Perhaps you can talk me through that.
Well, we'll start with the colour. The colour is the hard anodized coating, which is very resistant to chemical intrusion. As you can see, the bearings are very different. They are stainless steel. They are sealed from the outside face and the inside face against flushing out of lubricant under pressure washing. You also see that they stand up. There are no traps around the fixings, so there's no intrusions and underneath. So it's everything's clean and clear. Again, this applies to the hole in the top, which means that there is access for drainage. So if the system is sat like this, you don't get pooling on the inside of the mover.
Yeah, fascinating stuff. And when we sort of compare it to the normal GFX system, are there differences in its low capacity, the speed range, and things like that as well?
It is somewhat limited. It's comparable to our normal small compact GFX movers. It's not going to carry 10 kilos around a system,
okay,
but it will carry 2 or 3 perhaps.
Yeah. So it's definitely aimed at the right application in the right environment. Okay, no, that's a fantastic look and an incredibly interesting insight. Thank you, Tim.
Thanks, Alex.
Okay, so thank you for your interest in our latest developments. I hope you found this of great use so far. And really what we've just seen is how XTS is now moving into new applications and being able to solve problems that we couldn't do before. But of course, washdown isn't just the only solution that we're talking about here, is it, Dan?
That's right, Alec. So, of course, when we started the project, if you like, we were looking at washdown, so removing spaces for bug traps, as Rob has said. But very quickly, we started getting inquiries for a different type, if you like, that was just clean down, or I would call clean down. So really sort of medical, health applications, just areas really that needed to be cleaned down and remove the bugs in an effective way, if you like. So we've actually shipped those types of systems already, but we're also getting inquiries really for the more sort of aseptic primary packaging, really. So we're looking at harsh environments with hydrogen peroxide. That's the main chemical that everybody's mentioning. And that's very tricky to do, but we are working on it. So I can see eventually we'll end up with 3 types, if you like, 3 flavors of the hygienic design.
Thanks, Dan. That's great. Okay, so we will now go to your questions. So yeah, please, if you've got any questions, get them in there. And we're going to start off. First question we've got, which has been sent in by one of the team. Dan, with the hygienic system, how are the magnets covered and protected? Obviously, we're talking about these harsh chemicals.
Yeah, that's a good question. So yes, we've had to cover the magnets, but we do it with a very thin coat of stainless steel, if you like. It's non-ferrous, so it doesn't interfere with the magnetic field. So yeah, essentially that's what we've done. Yeah.
Okay, thanks, Dan. Okay, next question up. With regards to the hygienic system, are the peak and constant forces available still the same? Rob, can I bring you in to answer that one?
So while we did make the coils a little bit bigger on the stainless so that we can send the magnetic field a little further out, we keep about 80% compared to a standard magnet. So the peak forces on the stainless steel is 80 newtons and a constant force of 20 newtons, which is a little bit less than the 100 Newton for our standard magnet.
Perfect. Thank you, Rob. Thank you very much. Okay. Next question in. Tim, can I bring you into this conversation? If we have a hygienic system in a washdown process, how do you maintain adequate lubrication around the system?
It's a good question. It's probably a Beckhoff and Hepco solution. The lubricant is very likely to be washed away during a clean down process. So it does have to be replaced. It would probably require a lubricating after cleanup process. So at startup after cleaning, you run a lubricant profile, where it pumps more lubricant than normal onto the track and then distributes it around the system before you go up to full production speed.
Yeah. Okay. Thanks, Tim. And of course, obviously with the XTS GFX systems, lubrication is one of the things that we very much require to keep everything running reliably. Okay. Next question is coming from Yannick, and he's asking, will there be a clean room class 5, 6, 7, 8, etc. versions of Hygienic?
That's a very good question. Yeah, there are different classes. Well, we can certainly, that's a long answer, but we can take it offline and work with you on that. Yeah, no problem.
Okay. Right. Okay. Great question from Chris Hopkins. Thank you, Chris. And Chris is asking, does the washdown application affect the life of the unit? And if so, how much? Tim, can I put this one across to you?
Yes, I saw that question briefly. Another good one. Not really. It doesn't really have a huge amount of impact on the life. Again, it's the lubricant which is the issue. So as long as the lubricant is maintained, then we've got a reasonable service life comparable with the standard GFX.
Okay, and just to be clear, when we're talking about life, we're talking about sort of millions of cycles potentially. Great. Okay, thank you. Next question is from Dan Fletcher, and Dan is asking a double-barreled question here. Thanks, Dan. When will the Hygienic System be ready for sale? First question. And can the system withstand a high-pressure washdown? So, Dan, I'll go to you first of all for the when is Hygienic available?
Yeah, no problem. So very soon is the short answer. So it's been a long journey, but we're in the final stages of getting the official certificate, of testing it thoroughly, if you like. We're currently doing thermal cycles. So we're putting the hardware through thermal cycles up to 70 or 80 degrees, then letting it cool. And we're doing that a few times because we really want to be sure that the seals stand up, to those harsh environments. What was the other question?
So the other question is, can the system withstand a high pressure washdown?
Yes, it can. So we normally expect the environment to be, 40, 50, 60 degrees, pressure washers that people are using, mild detergents, things like that. But as Tim's already mentioned in the videos, the seals are designed to withstand that on the bearings themselves, on the movers, but also the motor modules themselves. But very, very good question.
Okay, great, thank you. And just another question, which I feel I can put it across to you, Rob. How does the XTS allow for thermal expansion, but still maintain a watertight seal between the electrical motor modules?
So that, I expand a little bit on what Dan has said, is that we did a lot of work on those connectors between the modules to reduce the air volume there as much as possible, because when you take the module from 2 or 3 degrees Celsius up to 80 degrees Celsius with hot water on it, you're going to get air pumping. So we've designed modules or connectors that actually have a watertight seal that allows the air to travel in without bringing the moisture in, and allows it so it's a true tight seal. And that was one of the things that we spent a significant amount of time on developing to make sure that works flawlessly.
Brilliant. Yeah, thanks, Rob. Okay, next question coming in thick and fast. Thank you, everybody. Kevin is asking, is the Hygienic System only available in oval configurations, or can we do more complex and regular shapes like we've seen some of our other XTS systems or the standard PRT2 version?
Rob, I think.
Rob, would you like to come in on that one?
Sure thing. The 45-degree module is now out. It's available. We can deliver a 45-degree curve module, which is going to allow more, all of our squares and other configurations.
Okay. Right. And I think now we're going to think, conscious of the time here, we're going to save up some of your questions for the end. We are going to have a final Q&A session. But now we're going to crack on and move on to the next session of the presentation, which is going to be looking at high drive. And again, you know, high drive is really about moving XTS into new areas, new applications. And, you know, if we look at the standard XTS, GFX that we're familiar with, or most of us are now, then, you know, typically we associate it with a few kilograms in terms of payload, you know, sometimes just a few 100 grams. But what about if we want to go heavier than that? You know, you've got a sort of a fairly hefty industrial application. What's the solution? Let's take a look at the high drive system.
With our high drive system and a larger mover and a larger magnet, we're able to move heavier loads just as fast as we're able to move light loads with smaller magnets. We can also lift more, so it allows us to do more work on bigger objects. So basically applications that were in the past not doable with a small mover and a small magnet are now possible, and other applications which were perhaps heavy can now move even quicker with higher accelerations and higher speeds. And here now we'll have our setup with 4 kilograms loaded on each of the movers, and we can run them with a 2G acceleration, and we can lift in the curve. And let's see this now running. So here we have our Beckhoff XTS system combined with a Hepco high drive and a high drive plus system. So for the high drive, we've taken a larger mover. This mover is 100 millimeters wide and it's got a bigger magnet on it. We've put a 100 millimeter magnet on that, and it has a peak force of 210 newtons. This is intended for larger loads and higher forces with larger loads. So this mover is now equipped with 4 kilograms combined with the 1 kilogram mover, and 200 newtons. We're able to achieve 4G acceleration and our top speed of 4 meters per second. When we need to go heavier or we need to put a cantilever on the mover, we go to the high drive plus. And with the high drive plus, we've now got another mover on the bottom that's supporting the extra load from the top. So we can put a much heavier load on the mover and we can cantilever it further out. A drawback to the cantilever is that when we enter the curve, the mover has to turn the entire mass. And for such a mover or such a configuration, then we will typically slow down in the curve. To avoid that and to go even heavier, we'll go to a high drive plus system with 2 movers coupled together mechanically. This way, when the mover enters the curve, the twisting force on the mover is picked up by the second mover behind it, and when we come out of the curve, it's transferred the other way. This allows us to put a massive amount of weight onto our movers. This mover configuration can carry a maximum of 90 kilograms. Here we have it set up with 20 kilograms. So we've got 20 kilograms on this mover pair, 5 kilograms on this mover, 4 kilograms on that mover, and all of these configurations can reach the maximum 4G acceleration and 4 meters per second motion. So let's now see it in action.
Well, thank you, Rob. That's a fascinating look at HyDrive, you know, a solution that really sort of allows us to move into new areas and new applications. Tim, quite impressive, the types of loads that Rob's just been showing us there. And, you know, using a standard mover as a reference point, clearly HyDrive is bigger. Can you tell us a little bit more about the actual mover itself?
Well, you're absolutely right. The HyDrive is bigger. It uses a larger magnet array, which starts off with more drive force, but also greater payload. We've gone from the very small bearings on the Agile up to much larger bearings on the HyDrive. Much higher capacity, much higher radial capacity and axial capacity. The mounting faces are much more substantial. And it's just bigger and heavier and well suited to these high loads.
Thanks, Tim. And I guess, you know, one of the big questions that our viewers are going to be asking is, you know, if you take a sort of a standard mover and compare it to HyDrive, you know, if I took a lump, some sort of product and stuck it on top of the mover, you know, what sort of capacity gains are we seeing with HyDrive?
We're looking at 100% gain. We're looking at twice the capacity.
Okay, well that's pretty impressive indeed. And I guess as with anything, there's going to be some sort of trade-off. If it's heavier, I guess you can't move it as quick.
That's exactly it. We have this larger mover is 40% heavier than a standard mover. The bearings are much larger. The overall mass obviously precludes high accelerations. We've got the rotating mass and the overall mass of the unit. But we're talking about big payloads, so we're not expecting to see Agile type accelerations on 20, 30 kilo payloads.
Okay, no, that's interesting. And you know, when we talk about those sorts of payloads, it's really moving XTS and GFX into new areas, new industries. I mean, I guess, you know, it makes us viable for sort of automotive type applications where you've got sort of larger assemblies than typically we'd be used to.
Absolutely. We're also looking at large crates of product. So with the end of line processing, where we're moving perhaps 20 or 30 kilo crate of liquids or solids into packaging areas.
Yeah,
so we've gone from processing all the way through to final packaging.
So you might have a standard XTS GFX that's doing the individual bottles or packs or something, and then you could have a HyDrive system which is moving the full boxes of multiple products.
Absolutely, and it allows that integration from one process to another with the same control system.
Brilliant. Thanks, Tim. Very interesting. Okay, that was HyDrive, and you know what I really like about HyDrive is it's a double whammy of benefits. You've got the more robust mover with the larger bearings, which effectively increases mechanical capacity, but then you've also got the added drive force of the new larger magnet from Beckhoff. So yeah, it's been quite an interesting development cycle, this one, hasn't it?
Yeah,
Dan?
that one was very fast moving. So from the concept to having a working system in Unveil in our headquarters in Germany was literally just 3 months. So, and the reason for that really is there was a development previous to that from Beckhoff, which is called mode 10. So it puts our soft drive in a different mode. So what we actually do is the motor modules on the bottom ring are copying, if you like, the current commands to the top ring. So they're a slave, if you like, to the top ring. So from our point of view, we weren't doubling complexity or setup time or anything like that. And for the Hepco team, that was nothing new for them either. So they were very used to doing double-decker systems, twin systems in the past. So, you know, 3 months from concept to having a working system, I thought was pretty good.
Yeah, absolutely. And again, this is driven by customer needs. We're the challenge to us to solve customers' problems. So, really good that we were able to step up to this. Okay, so let's move on to some of your questions. And first up, I'm going to go over to you, Tim, for this one. Is the spacing between the tracks fixed or customizable? So this is between the double decks that we saw.
Totally customizable. I would say that there's an upper limit, probably 900 millimeters, a meter perhaps. But it's all really down to the control between top and bottom XTS. So in theory, we could go higher, but long, slender elements always make me nervous.
Yeah, that really sort of depends on the cantilever as well. As Rob explained, the higher the mast, the further it is out from the center line, if you like, of the driving force. So, the further out it is this way, we can increase the distance of the top and lower decks to take that effect away.
Yeah, brilliant. Thank you. Okay, next question up. Dan, if you could pick this one up. Can we offer a solution for increasing the drive force and capacity on the smaller oval systems that use the Beckhoff 180-degree motors?
Yeah, that's a very good question. So obviously we've been talking about the high drive and the high drive plus, which is the 10 pole. So the 10 pole is really designed to go through our larger curves, so the 22.5 and the 45. But as this customer has asked, they're asking higher forces in the clothoid. And yes, this is very doable. We now have a 7-pole array, which gives us that bit of extra force and, can prove very beneficial to certain applications. Yeah.
Okay, great. Thanks, Dan. Okay, Rob, over to you. Question on accuracy and repeatability. What is achievable with the high drive system when you compare it to, say, a standard GFX XTS?
It's absolutely identical. For repeatability, we still get the same 10 micrometer repeatability. For in motion, we're also the same for our accuracies. We tested that high drive system extensively, and even running through the curves at a very high speed, 1.5, 2 meters a second with 30 kilograms loaded, we could make sure that those movers are less than 0.5 millimeter from their target position underway. And the amount of inertia and the energy that we're changing in that mover as it goes from the straight to the curve and back to the straight again. So the accuracy and everything stays exactly the same as it was before.
Brilliant. Thank you, Rob. Thank you. And just while we're talking about sort of the high drive capacity, there's a question here from Charles, and he's asking what would the maximum payload be for high drive systems, for the high drive system, if the accelerations were reduced to a minimum?
I'll take that one. Yeah, for example, with the 4-mover setup that we had there, that gives us 800 newtons of force. So if we put 90 kilograms on that, then we're looking at about a little less than 1 G acceleration. So those kinds of masses are possible. When we start making that gap bigger and even further cantilevering out, then it's physics as to what we can put on it. But for size, I can always put more magnets on it, and we can, there's kind of no top end.
Okay, that's impressive. Thank you very much. Okay, Dan, there's a question from Emilio here, and he's asking, do we recover energy when decelerating?
Yes, we actually do. So in the early days of XTS, things are a bit more complicated, if you like, with putting energy in and out. But yes, we do it on a regular basis, as you can imagine. So, on the larger high drive and high drive plus applications, that is a lot of energy. So yes, we do absorb the energy, if you like, the energy coming back into the system as we're decelerating. Yep.
Okay, great, thank you. And Lily's asking about the maximum forces of high drive and high drive plus. So hopefully, sort of Rob just sort of answered that on the question before. What I would reiterate If you've got any questions or anything you want any further clarification on, we will be opening up right at the end for sort of a free-for-all on what you've seen today. So anything that you think we've missed or you want more explanation on, then please feel free to drop those in at the end. Okay, just one more question that I've got here. I'm going to put it across to Tim. And this talks about using high drive with an application that may have a press force applied to the mover, and they're asking how much force can be applied to that mover. And I know when we refer to a standard GFX XTS system, then it's about 100 newtons as a static force.
Yes, I mean you can apply that 100 newtons, 10 kilos onto a standard unit. We would look to apply maybe twice that. So you'd be looking at, say, 200 newtons, 20 kilos. The bearings are that much stronger. The whole stiffness of the unit is higher. So yes, on a single mover, we should be able to take somewhere around 200 newtons.
Okay, so it's really not just about the payload we're carrying, but the operations that are taking place on the mover are increased as well. So yeah, really expanding that envelope that XTS can operate in. Okay, well, thank you once again for your questions. And we're now going to move on to the next segment where we're going to be looking, and I'm sure you've been wondering what this wonderful contraption is behind us. It's the track management system. And really what we're looking at is a solution that enables you to switch movers between systems. And you know, why would you potentially want to do that with your machine process? Well, let's take a look.
This is our track management system. And with track management, we have the ability in the software to rearrange the motor modules into any order on the fly. Then we simply reposition the motor modules mechanically, and the movers will transition from one section of track to the next section of track smoothly. This allows us a whole myriad of new applications. The switches don't need to be simple switches as they are in this case. What we can do is we can set up multiple diverse track sections and move the movers around through the system wherever they need to go. We simply reposition the motor modules into the new order, and now I have a new switching system, very similar to a railroad train yard. It also allows for simple setups like this, where we simply have two switches. And the switches then can be positioned very close together. So here we have two rails that are very narrow, and we can move movers from one side to the other side, making a very compact XTS system, and I have the added benefit that the mover never has to rotate in the other direction. If I do applications where I have two movers holding the same product, this makes it very simple. I no longer need to drive through a curve holding the product. I simply drive onto a switch, move up, and I drive off the switch. We also have the capability to store extra movers. So I can have a section of track underneath the system where maybe I have 20 other movers with a different tooling. Those movers can then automatically be brought into the system in an automated tool exchange. Or in applications where I change the length of the part drastically, when I have a longer part, I may have too many movers in the system and the empty movers are getting in the way. So when I run long parts, I can automatically move out extra movers. And when I switch back to shorter parts, I can on the fly bring in those extra movers and run then at a higher rate. So here we have the system running a very simple setup, two movers on one side, one mover on the other side. Now we'll speed everything up.
Okay, well, thanks, Rob, for really demonstrating the principle of the track management system. So here we are back in the Tiverton studio. Tim's joining me, along with the very latest generation of the track management system, which is a production demonstration unit. And we have got it turned down nice and slow. Firstly, because we don't want to make too much noise while we're filming, and also it's in the early stages of commissioning. But Tim, so I do want to turn this up. Realistically, what sort of performance can I get out of this system?
Well, from the track management element, I would expect to achieve 200 milliseconds for that stroke. That's taking about 3 seconds at the moment.
Okay, and what about the sort of rest of the GFX track system itself?
Well, the GFX track system itself is exactly that. 4 meters a second, 100 meters per second squared acceleration. It's absolutely standard.
Okay, so we could be shuttling the carriages into the track management switch at 4 meters a second, the switch operating at 200 milliseconds, and theoretically doing that 24 hours a day.
Yes.
Okay, and of course, I know when a machine is running for an extended period, then you get things like heat build-up, and you need to maintain a very high level of accuracy on that transition. How do you realistically do that?
Well, we've got two methods. There's one that's built in, which is the position of the encoder and the encoder strip. So it's neatly balanced and enclosed. So any thermal variations have the minimum effect on the position. And the other one is we do actually monitor temperature. So temperature extremes can be accommodated within the software for the track management.
Yeah, and it just goes to show how sort of Beckhoff and Hepco have really worked together to come up with a system that works so incredibly well, incredibly reliably. And talking about reliability, I mean, how durable is this system if we are talking about running 24 hours a day?
Well, we are looking at tens of millions of cycles for that unit. It's a large ball screw. It's good quality ball rails, good quality everything in there really, and it's driven by a Beckhoff servo motor underneath.
Fantastic, and just sort of looking at this system, I noticed that the top level is a sort of what I would call a typical sort of oval GFX XTS system, but underneath, the system there is noticeably different. What's happening down on that bottom level, Tim?
Well, as engineers, we like to play, and it was a wonderful opportunity to integrate all of the different the motor elements from Beckhoff. So we have the standard 250 millimeter straight unit. We have a 22.5 degree internal curve, a 22.5 degree external curve, 45 degree curves, and 180 degree clothoid curve, which is used on the upper level there.
No, it really is a magnificent piece of technology and engineering, so incredibly interesting. But, when we're talking about the sort of applications we might be looking at, and Rob's touched on how you can operate with this system, what realistically are we looking at in sort of real world type of applications that we might encounter?
Well, fundamentally, we can switch between complete track systems, so as you can see there. That allows us to remove for inspection, remove for disposal or correction, or transition to a completely different process without losing track. The Beckhoff software, XTS software, allows constant tracking of each component as it goes around the system.
Yeah, very interesting. And obviously the fact that we've got these stack systems, we can have maybe 2 or 3 stacks high, really taking XTS and GFX to another level. I guess ultimately that's going to save on footprint.
Yes, I mean there's no reason that we cannot stack 3 or 4 levels. Perhaps speed and fundamental inertia of a large mass moving around is going to slow things down. But there's no reason to think that we cannot stack processes one above each other rather than out across a larger floor area.
No, it's incredibly fascinating, and going forwards, we're really looking forward to seeing how our customers are going to be using this technology, working with Hepco and Beckhoff, to really optimize their production lines, maximizing throughput, all with the well-proven Beckhoff and Hepco technology backing it up. Please get your questions in now, once again, about the track management system, which is really quite an ingenious development between Beckhoff and Hepco. And, when we look at this technology, I'm quite impressed by the fact that essentially what we're doing is we're taking multiple processes and putting them together on a single platform. Whereas before you might have had separate processes within a line that have to, the product transfer has to take place with a separate element. And really what we're doing here is making that into a modular format. And of course, we're using the tower block principle of building upwards rather than outwards.
Yeah, that's right. So as Alex just mentioned, with the track management switch, we can link modules, link processes, if you like, in a modular way. So, a factory might expand a certain process, a manufacturing system, and we can link those, say, with a lower level, and it acts as a buffer as well. But the important thing is really we can track the product through the process as we go without the need for robotics and taking the product out of its nest, etc.
First off, let's ask Dan, realistically, how many modules wide could the track management switch be?
Yeah, that's a very good question. So behind us, you can see it's one module wide. It's actually a 249 module, of course. So we've created a module that's slightly shorter length, specifically for this purpose. On the video that you saw behind Rob, we've got a twin module switch, if you like, and a single module. We think probably we can go to 3, actually, is the quick answer. So on a single axis track management switch, we can go 3 modules wide. But again, it is modular. But if we go any wider than that, we'll probably need more spindles, more ball screws, if you like, with 2 motors synchronized. It's all possible, yeah.
Okay, Dan, and next question up. When can we have one? When's it available?
That's a good question. So we've started the beta program already, actually. So if any of you out there have a firm requirement for them, we've come out of the testing phase, if you like. We're still running them in the background, but we are ready for beta customers. And of course, we'll support you as ever we do, really, but we'll support you through that process and are here to work with you. Yeah.
Okay, thank you. Next up, a question from Yannick, and he's asking, can we switch horizontally? Tim, perhaps you want to come in on that one first, and then we'll go over to Rob.
Yes, there's we can switch horizontally. We haven't built one yet, but we do have a design that could probably work. There's different problems involved with going horizontally as there is to going vertically, but there's something that we can look into.
Yeah. I mean, the principles are the same, I think, essentially.
Okay.
If you know what I mean, between the vertical and horizontal.
Just to add in there, and just from my understanding, obviously, if you've got 2 tracks side by side and you're switching horizontally, you're effectively, would you have to rotate the orientation of the mover?
Yes. So you would, yes, you would. Okay. Yes, you would. So yes, the short answer is yes, it's doable. Yeah, we've looked at it already, and the principles are the same for switching horizontally as vertically. A number of people have asked us already, but a very, very good question. Yeah.
Okay, thank you. Okay, next question. I'm going to put this over to Rob. Cyril's asking, what's the maximum maximum speed the mover can engage on the TMS system?
So when the mover is actually on the switch, it can be in motion, right? That's a normal controlled section of the XTS. So if you have a longer switch, maybe even the 500 millimeter long switch, as you're in motion, the mover can be coming in basically at full speed. Then we start the switching process and the switches now move down and the mover goes out at the full 4 meters a second. You want to make sure that the switch is actually in place before you come flying off the end, but that's no issue. Coming in at full speed, going out at full speed, making movers move on the switches. You can come in one direction, go out in the other direction. Really, the system doesn't care that the switch is in motion.
Brilliant. Okay. Thank you, Rob. Right, Dan, I'm going to put this one over to you first of all. If something goes wrong, like an accidental or external tool which might block a mover, is there some sort of safety control to cut off the power supply?
Yeah, absolutely. So it's a good question again. Safety as ever. So what we can do is build up a profile, if you like, of the energy that it takes to move the carriage up and down, the switch up and down. And if we go outside those bounds, we can basically stop the system in almost like an emergency way, if you like. So yeah, it's a good question.
Okay, great. And then next question is, can the track management system work with all types of XTS systems? So the 180s, the PRT2?
Yes, it can.
Yeah, essentially.
Yeah, it can. I mean, you can see here. So this is, again, different from the smaller track management system demo that you've seen Rob show. So here we have the clothoid system here. We've got 3 roller movers, but the geometry is such that these movers can move around the clothoid as well as positive, negative curves. That's our 22.5 degrees and our positive 45. So this is, customers have already used this in essence, if you like, because we have a hybrid version of the PRT2 tracks and the clothoid. So customers are already using this configuration, if you like, of mover and track, but without the switch. But I think the switch links those two together nicely, really.
Great, thanks, Dan. Okay, well, thank you once again for your questions. We're now going to move on and take a look at our final segment, which will be the Agile system. And just make sure you don't blink, otherwise you may well miss it. This thing is fast. Let's take a look.
With the Agile mover, we've gone in the direction as light and as fast as possible. We've shaved as much weight out of the mover as we can. The mover now has a mass of around 350 grams and can accept a payload of 150 or 200 grams. Combining that with a 100 Newton magnet, we're able to reach 20 G in acceleration. That means the mover can go from stopped to 4 meters per second in just 50 millimeters. That's the length of the mover itself. That's necessary for a lot of our high-speed applications, things where we want to use a sensor to detect a part and then catch that part. With a super high acceleration, I can put the sensor nearer to the mover. So now I can place a sensor 100 millimeters from where the mover is parked, detect that a part has come, and within 50 millimeters of the mover, I've now accelerated up, caught that part, and I can now process that part further. So everything now gets smaller. And I can do more things with this. Rather than using that 100 newtons just to get a nearly 1 kilogram mover around the system and using all the energy to push a mover and nearly none of the energy to push maybe a 10 or a 50 gram part. Now we go in the other direction where we're much more efficient. All of the force is going into moving the part rather than moving the tooling. We can also take it the other direction and say, okay, what can I do with rated current? Rather than just using the peaks, I want to continuously, in a section, apply a lot of acceleration. So now with rated current, I can get 6G acceleration out of a system. And now I can do a lot more things with higher part rates. It used to be that at 600 parts per minute, we were pushing the boundaries of what we could do with an XTS. Now we can double that. 1,200 parts per minute is relatively easy, and perhaps even faster, 1,500 parts per minute. It's all a question of really what do we do with these forces now. Now that I have much more rated current to be accelerating movers rather than trying to just simply accelerate a big piece of aluminum. The system has also gotten quieter. So here behind me I have a system running at full speed or nearly full speed. It's only running with 15G acceleration. And it's quiet enough that I can easily talk over it. So let's see what we can really do with this system, and let's make it go full speed.
Well, brilliant, fantastic insight there, Rob. Incredible performance, and well done for actually managing to film it. It's eye-wateringly fast. They say dynamite comes in small packages. Tim, great job. And you know, when we're actually looking at the detail of the movers, you know, I can see that this standard mover I've got here, it's substantially larger than the Agile mover that you've got there. Talk me through some of the differences.
Well, the most obvious difference is the size of the bearings. They're much smaller. They're also more compact to the mover body itself, so there's less of a lever in the drive force. The body is lightened and again made more compact to give us a bare mass of around 200 grams.
Okay, no, that's interesting. So, you know, for my understanding, you know, what does that actually mean in terms of how does it go faster?
Well, basically the lower mass allows us to accelerate much faster to top speed, but not just accelerate. It allows us to decelerate much faster as well. So your transit time from point to point is significantly less, allowing a far higher throughput.
No, that's very interesting. So essentially what you're talking about is if you had two cars in a race, you know, they both got the same top speed, but one, you know, is a Ferrari acceleration and slamming the brakes on, and the other one's a Focus or something. So yeah, I'm with you. Right, brilliant. In terms of the type of application we'd be looking at, well, you know, talk us through typical sort of uses.
Well, our target applications are very low mass. So we're looking payloads under 200 grams. We are looking at probably confectionery or bakery products, high volume, high throughput, relatively low value component cost, where we just need parts per minute. What we're looking for is parts per minute.
Oh, fantastic. Yeah, very interesting. Yeah, thank you, Tim.
Thank you.
Okay, so this is the Agile system, the Agile mover. What a little pocket rocket. Love it. So, yeah, I mean, Dan, you know, when we look at the Agile system, it's, you know, as engineers, we're always fighting against physics, aren't we? You know, to accelerate a mass, it requires energy. And of course, that energy acting on the mass, it has reaction forces, which creates all sorts of issues, not only in terms of driving it, but in terms of the mechanical reactions going on in the system. So what really Agile is trying to do is claw back some of those losses that we lose to physics. And yeah,
absolutely, that's right. So as Rob said in his video, was, you know, we are looking at parts per minute of traditionally about 600-700 maybe, and we are looking now at higher parts per minute values of 1,200 or more. So I think that speaks volumes in itself. Of course, you know, we're increasing throughput, but the other important thing is energy use. So we're all trying to use less energy. The other downside, of course, on any engineering system is energy normally means heat. And, you know, some of these environments get pretty hot. So the less heat we can generate, the better. Everything lives longer, and we're helping the planet as well.
Excellent. Yeah. Okay. So let's go to your questions. So please get your questions in about Agile. And first up, when is it going to be released? Tim, do you want to drop in on that one first?
Yes, absolutely. We are pretty much there. Again, as you said earlier, it's seeking beta customer, really. We're at that stage. We've been through significant testing. We've had a little bit of feedback from some customers, just some suggestions, nothing about the mechanics, more about the functionality of the mover itself. So yes, we're ready to go.
Perfect. Sounds great. Okay, Rob, if we were looking at sort of throughput on the Agile system compared to standard XTS, what's the sort of the markup in increase on throughput that you could expect?
So one example is something that we looked at a couple of years ago, an application trying to run 400 movers a minute, or 400 parts per minute using 2 movers together. And we determined that with the 2G acceleration, that was going to be our top end. Well, now with rated current, right, because we have always a mover in motion, there is no downtime for any of the coils, right? So we have to live within that rated envelope. Now that rated envelope is 6G instead of 2G. So are we going to go 3 times faster? No. But are we going to get 50% more out of it? Yes. So now 600 parts per minute or 600 pairs of movers per minute is now going to be doable. So applications like that, we're going to immediately revisit.
Very, very impressive. I was going to stick with you here, Rob, because there's another sort of question on the speed. And the question is really, what sort of time could you expect to make, say, a 300 millimeter index with a 200 gram payload that we talked about?
So if we use the full 20G, the motion 300 millimeters stop to stop, and we allow, say, 20 milliseconds for the mover to come perfectly still, we're looking at 120 millisecond motion. So doing that motion 5 times a second is fairly straightforward.
Yeah. Okay. Great. And there's some great questions coming in here. And there's an interesting one asking if we can cut trees with it if we put knives on the movers. Well, you know, it's fast enough, but yeah, not really the design purpose of XTS. Okay. Can we run at 4 meters per second in the 180 degrees curves and maintain lifetime? I mean, Tim, maybe you want to pick up on that one first in terms of the life question?
Yes. If we are talking about the payloads that we've been discussing, I mean, Agile is designed for relatively light payloads. Yes, the life is absolutely comparable with a standard GFX. It's all about bearing. Life is all about bearing loads, and the bearing loads are less. I mean, the whole thing is just that much lighter. The loading in the curve is actually less in some applications. The smaller mover, from our calculations, has a longer life than a standard C25 type mover, the very smallest one that we do. That one just there.
Okay, great. And yeah, I know that you said that already the Agile system is done sort of millions of cycles in testing and proven to be incredibly reliable. So yeah, great stuff. Next question, Dan. Cyril's asking, is the Agile mover fitted with the standard 50 millimeter long magnets?
Yes, it is. That's a good question. So yes, it is. And we can also use a 4-pole. So about a year ago, obviously we generated a whole suite of different size magnets, and the 4-pole was one of them. And obviously we have less force with the 4-pole, which is, you know, less relevant, I guess, if you've reduced the mass that much. But you can bring the movers closer together. So we have, even from the early days of XTS, we've had customers that want to bring the movers close together. So close, in fact, the magnetic fields interfere, if you like. But with a four-pole magnet, we can actually bring the movers within 2 or 3 mil, maybe closer. We're really just talking about the accuracy of the tuning, how effective the tuning is, but we can bring them almost touching, basically, which is a great advantage for some people. They really do want to squeeze those movers together.
Okay, and that sort of leads quite nicely on to next question, which is a good one. And they're asking about these sorts of speeds that Rob was showing, which, sort of eye-melting. What would happen in the event of emergency stop? How is the deceleration of those movers controlled to stop them, crashing into each other and piling up?
Yeah. Well, we basically have safe torque off, if you like, so we remove the power. But the movers can be uncontrolled in some emergency situations, but we do have other tools available. We are looking at new safety tools, but also we can zone. So it's very, very common for customers to zone an application, say like the one behind me. So we don't actually remove the power from all the movers simultaneously. But if you remember that most of the movers have a similar mass, even with or without product, what generally happens if you remove the power in an emergency manner is that they just basically slow down at a similar rate.
Thanks, Dan. Okay, Tim, next one I'm going to go over to you. It's relating to lubrication of the system. And it's being asked, can we specify a predictive operation with a dedicated logarithm and sort of reporting of worn components?
Yes, I believe that is possible, but that's actually something that's probably better directed to Rob, particularly in terms of the predictive maintenance and
okay, Rob,
being able to record that information.
So there's two things I want to talk about. One is to add on to what Dan said about that emergency stop when we have a fault. It's already built in, right? All of our motor modules currently, when we detect a fault situation, there is back force applied on the movers. And depending how we do it, if we actually short the 48 volts as well, we get a force acting back on the movers. Well, that force is relative with the speed. So the faster the mover is going, the higher the force is. So there already is a significant braking force on those movers in the event we have an uncontrolled situation. So they're going to come to a stop very quickly because they're so light. Now, on to things like wear and all that sort of stuff. There's a ton of values that we can take back. And temperature reading and energy consumption. So how much current am I using at a certain speed? Those are extremely good values to look at for, is the track dry? Are my movers needing more tension, or is something loose? Does this thing take absolutely no energy anymore? Well, if it does, then that means it's not tight to the track at all. So we've got a myriad of parameters that people can look at and then say, okay, I can now develop my algorithm for this. It is a little bit application dependent because the things I need to do to monitor a 4 meters a second application are a lot different than what I do to monitor a 1 meter per second application, right? So the parameters are going to be different. But all of those tools are there. The values are brought back into the PLC. It's just a matter of taking a look at them.
Yeah, great. And just to add to that, at the front end of any application, when we're discussing and look at your application, we consider all your application parameters, and we check the system for suitability for your application. So we know what your life is going to be. It's a controlled amount of lubrication on the system. So we can tell you before you've even started this system running, it will last for 5 years, for example. Okay. Next question we've got from Barry, and I'm going to put this one across to Tim again. It's a mechanical question. To what extent is the GFX XTS system applicable in dusty and dirty environments?
Well, this is very much the V-guide technology. The V-type bearing has a tendency to clear its own path. So yes, it is the fundamentals of the V-guide that to an extent, it's self-cleaning. Does that
yeah.
answer the question?
Absolutely. I think, we touched on that at the top end of the show. We talked about the benefits of the V-guide technology and the wiping action as it travels along the guide. So, yeah, in that respect, we're pretty comfortable with dirt and dust. Okay, so we're going to wrap up the questions on the Agile system for now. And there will be a final opportunity to get any questions in. So if you're still sticking around and you've got any burning questions you want to ask, put them in now. But really, I just want to sort of really reiterate what we've covered today. Sort of the start, we looked at the hygienic system, which really allows XTS to operate in harsh environments, wash down, wipe down, and as Dan mentioned, aseptic type applications. And then we moved on to the high drive system, which again is expanding the envelope of capability of the XTS system into higher payload applications. So we can really consider types of industries and applications that we may not have been able to before. And then next up, we had the extremely well engineered track management system and the technology that's backing that up with the Beckhoff control software, which I think really is going to be a game changer when we look at production lines in the future. And of course, as we've just seen, we finished up with the Agile system, which is really sort of breaking the barrier in terms of the speed capacity and throughput that we can do with an XTS and GFX combo. Okay, so if you have any final questions, now is the time to get them in. I'm going to kick off with one towards Tim, which came in earlier from David, which is a great question. Can an Agile or a high drive system be used on track management system? So can we put one of these Agile or high drive systems onto this?
The simple answer is yes. I like short answers like that. Absolutely. No problem at all.
So yeah, anything to add to that, Dan, in terms of drives and controls? It doesn't make any difference?
It doesn't. The only thing to remember with the Agile mover, if I get it quickly, is, and Tim will back me up on this, the geometry is slightly different. So to really reduce the mass, the center line of the rails is closer, if you like. So if you had an Agile system on one circuit, you would need one on the other circuit, if you like, because the tracks are slightly higher. But apart from that, you can use the TMS on other track sizes.
Okay. Rob, got another question which I'm going to put over to you. Is there a safe speed feature for commissioning works integrated in the Beckhoff system control?
For a safe limited speed, an actual safety yellow type function, no, there isn't. So everything at that point has to be controlled and monitored, and trained personnel operating around the system to make sure, because there is not a true integrated safe limited speed. Okay, great, thank you.
So another question, is combined motion with Beckhoff motors possible? The XTS is an X-axis and some other motor as a Y or Z axis. Dan, do you want to pick that one up?
Yeah, absolutely. So Rob will sort of testify, probably has more examples than myself, but yes, we do it all the time. So we synchronize with other axes within TwinCat and indeed robotics. So we do it all the time. And there's a lot of videos actually to show you that online.
And I guess essentially that's pretty much what we're doing here, isn't it? To some degree.
Yes, kind of. I mean, as Rob said earlier, we need to synchronize the motion of a servo motor axis driving up and down and the mover axes themselves. So yes, that's really it in action.
Okay, and a question from Barry, which I'm going to pick this one up. Is the GFX XTS system also used in other industries than packaging? Well, absolutely, yes. I mean, pretty much any industry you could think of. I think we could probably put an XTS or a GFX system in there. I mean, we've done sort of COVID-related applications, and you can understand why, because you want to get your throughput as high as possible. You want a high yield electronics, automotive, scientific research and development. Anything else to add there, Dan?
No, that covers it really, yeah.
Yeah. So yeah, I think pretty much, you know, if you've got an application where you've got some sort of product transfer or process going on, then I think, you know, you could consider XTS GFX as a solution. Could we supply a vacuum or air pressure or energy to the movers to hold parts? Rob, I'm going to drop this one over to you because I know you've done a little bit of work on this.
So there's some technologies out there that allow like a wireless pickup. So some people have looked at doing things like that. We've had customers successfully apply that sort of technology, but it's a matter of making those mechanical or the connections to bring that onto the mover and then run through the system. So for circular systems with hoses and things like that, that works. Ovals, somewhat, but if the oval is really long, then my hoses have a lot of problems. But some customers have managed to figure out the mechanics behind this.
Yeah, just to add to, thank you, Rob, and just to add to that, the flexibility of XTS really allows you to actually combine movers together. So, you know, you can actually use a pair of movers as a mechanical gripper to pick up your product. You know, it's got that feedback that allows you to do that in the process.
Absolutely.
Yeah. Okay, I'm going to wrap it up, and I'm going to say thank you very much to all of our co-presenters. So Dan, thank you.
You're welcome. Pleasure.
Rob, thank you very much for joining us all the way from Berlin, Germany.
My pleasure.
And finally, Tim, thank you once again for your expertise today.
You're welcome. Thank you.
And most of all, thank you to all of you for joining in, participating. And of course, like I say, if you've got any questions, please reach out to us. This is all being recorded, so check out our YouTube channel and keep an eye on our social media, and we'll keep you up to date with all the latest developments. Hope to see you again soon. Thank you very much.
Thank you.